Hi guys! Welcome to Science Moment, a place to ask the big questions, to seek the hidden truths, and to marvel at the sheer scale of the universe we call home. A cosmic epic, from the Primordial Nebula to the miracle of the solar system. Chapter I. Beginnings from the void and the testament of ancient stars. The story of our origins does not begin with brilliance, but in the silent darkness of interstellar space. Approximately 4.6 billion years ago, in a remote region within the Orion arm of the Milky Way, there existed a colossal cloud of gas and dust known as the Solar Nebula. This cloud was not merely hydrogen and helium, it held the ashes of previous generations of stars, heavy elements like iron, gold, carbon, and oxygen, forged within great nuclear furnaces and scattered across the cosmos through supernova explosions. The stillness of the nebula was shattered by a cataclysmic event. A neighboring star ended its life in a terrifying supernova. The shockwave from this explosion compressed the nebula cloud, disrupting the balance between thermal pressure and gravity. The cloud began to collapse in on itself. According to the law of conservation of angular momentum, as its size shrank, its rotation speed surged, transforming the chaotic mass of gas into a flattened, steadily spinning protoplanetary disk. Chapter 2. The awakening of the Sun. A heart of fire. At the epicenter of this swirling disk, the density of matter became unimaginably high. Under the crushing pressure of gravity, the temperature at the central core reached an unthinkable level, about 15 million degrees Celsius. At this threshold, a physical miracle occurred. Hydrogen nuclei overcame electrostatic repulsion to collide and fuse into helium, releasing a gargantuan amount of energy. According to Einstein's famous equation, E equals mc²2. In that moment, the Sun was officially born. It was not just a ball of fire. It was the king holding 99.86% of the entire system's mass, creating a deep gravitational well that governs the orbits of every celestial body. In its early stages, the Sun emitted powerful solar winds, sweeping light gases like hydrogen and helium out of the central region, leaving only heavy dust and metallic particles behind. This was the fateful screening process that determined the nature of the planets to come. Chapter 3. The War of Accretion and the formation of terrestrial planets. While the Sun stabilized its throne, the remaining 0.14% of matter in the disk began a grueling journey. Tiny dust particles, initially smaller than a grain of sand, began to collide and stick together due to electrostatic forces, gradually forming planetesimals in the region near the Sun. Extreme temperatures prevented volatile substances like water or ammonia from condensing. Consequently, the inner planets, Mercury, Venus, Earth, and Mars, were molded from the most resilient materials, silicate rock and iron. This was an era of violent collisions. The early Earth was once a glowing ocean of magma, and it was these titanic impacts that shaped our iron core and rocky mantle. Most notably, Earth fortunately settled within the Goldilocks zone, where temperatures are neither too hot for water to evaporate completely nor too cold for it to remain eternally. Frozen. Chapter 4. Gas giants and the frozen kingdom. Beyond the frost line. Beyond the boundary known as the frost line, where temperatures are low enough for water, methane, and ammonia to freeze into cosmic snowflakes, matter became far more abundant. Here, Jupiter, the first giant, rapidly accumulated vast amounts of gas from the nebula before it could be blown away by solar winds. With a mass 318 times that of Earth, Jupiter became the solar system's vacuum cleaner, shielding the inner planets from excessive meteorite impacts. Following Jupiter was Saturn, with its magnificent ring system composed of billions of icy fragments, and the two ice giants, Uranus and Neptune. These planets have no solid surface. They are worlds of gas and extreme pressure where storms can last for centuries. Their presence creates a delicate gravitational balance, keeping the structure of the entire system stable for billions of years. Chapter V. Time capsules and the mission of asteroids. The solar system consists of more than just major planets. Between Mars and Jupiter lies the asteroid belt, failed remnants that could never coalesce into a planet due to Jupiter's gravitational interference. Further out at the fringes are the Kuiper belt and the Oort cloud, home to billions of icy comets. Scientists today, through missions like OSIRIS-RX to the asteroid Bennu, are searching for the final pieces of this historical puzzle. These asteroids are primordial time capsules, preserving organic compounds and water from 4.5 billion years ago. It is believed that the impacts of these asteroids on the early Earth delivered the seeds of life, transforming a dry, rocky planet into a vibrant blue world. Chapter 6. The late heavy bombardment and planetary migration. The solar system was not always as peaceful as it is now. Around 4 billion years ago, an event called the late heavy bombardment occurred. Changes in the orbits of the giant planets hurled millions of asteroids and comets into the inner system. The clearest traces of this era are the massive impact craters on the surface of the Moon. However, this destruction brought positive value. It delivered water and carbon compounds to Earth, paving the way for the chemical evolution that led to life. This teaches us a lesson about the cosmos. Destruction is often the prelude to a grand new beginning. Chapter 7. Epilogue. We are the voice of the stars looking back. At this 4.6 billion year journey, we see a breathtakingly perfect arrangement of physical laws. From an anonymous cloud of dust, through explosions, devastating collisions, and patient accretion, an orderly planetary system was born. We, the human beings standing on Earth looking up at the night sky, are essentially the products of that journey. As astronomer Carl Sagan famously said, "We are a way for the cosmos to know itself." Every atom in your body was once forged in the core of a distant star and once swirled within the ancient Nebula disk. Understanding the solar system is not just about learning astronomical science. It is a journey back to our roots, realizing that we are an eternal and precious part of the great epic called the universe. Our journey through billions of years of the solar system's history concludes here. We sincerely thank you for spending your valuable time with us to look back at our magnificent origins. We hope that after this video, every time you gaze up at the night sky, you will feel a sacred connection between yourself and the distant stars. Do not forget to subscribe to continue exploring other mysteries of the universe with us. See you on our next journeys.